Okay, we're going to take a look at properties of dilations. For this lesson, you're going to need a compass and a ruler and a separate sheet of paper. We're going to start off by using that separate sheet of paper, and we're going to build some conjectures, which is just another word for hypothesis. You're going to take your piece of paper and fold it into fourths. And once you've done that, at the top of each fourth, you're going to write line, segment, ray, and angle. And you're going to draw a picture of each of those underneath your headings. Once you've done that, I want you to write down what you think will happen to each of these 4 items after they go through a dilation, and make sure you explain why you think it's going to happen. Once you have completed that, go ahead and continue the video. Alright, in this lesson we're going to investigate what happens to each of these figures after a dilation, and that is we're going to test our conjectures, which is similar to a science experiment. So we're going to start with classwork example number 1. I'm going to actually build it from scratch, but this example is going to show us that when we do a dilation, it will map a line to a line. So it's also going to be a line once it goes through a dilation. So to define, we're going to give line L, and we're going to dilate it with a scale factor of r equals 2 from center 0, or I'm sorry, not 0, but O. And before we begin, what I'd like you to write down in your math journal is another conjecture, exactly how many lines can be drawn through 2 points. Okay, so this is a review question. Once you've answered that, go ahead and continue the video. All right, you should have answered that only one line can be drawn through 2 points. All right, so what we're going to do to dilate this line, we're going to choose 2 points on L. We're going to call those P and Q. And once we've connected those dilated images of P and Q, which we're going to call P prime and Q prime, you're going to notice that we're going to have a dilated image of line L, which we're going to call L prime. First, from center O off of a line and 2 points on Q, or P and Q on line L. Those are already on your classwork worksheet. All right, so let's go ahead and I'll go through a demonstration. So here we have a line. Okay, we're going to call this L. And we have a point off of a line, which we're going to call O. This is going to become our point of dilation. And then we're going to pick a point on line L, which we're going to call P. And we're going to pick another point on line L, which we're going to call Q. All right. So now, because we have some extra points, we can take those points and draw a line, or a ray in this case, because it's got a beginning point. And we're going to do the same thing with O through Q. We're going to draw a ray starting through O and going through Q. Okay? So you can be following along at this point with what is on your classwork packet. This is where your compass comes in. So if you take your compass, we're going to measure the distance between O and P. And you're going to use the point of your pencil and the point of your compass. And you might have to adjust those a little bit. But once you have that figured out, then we're going to take the compass, put the point at O, and you're going to draw a line that goes through P and also crosses O. And it might take a little bit of practice. Mine is slightly off. Okay? But what's going to happen is we're not going to change our compass. That it becomes our measurement. Now we're going to put our point of our compass at P, and we're going to draw another line that crosses our ray. Okay? So now that becomes what? Not P, but P prime. So where this connects, where this crosses, is going to be our P prime. We have just dilated P. This would be 1, and when we do it again, this would be 2. So now we're going to do the same thing for Q. Notice how you're going to have to spread these out because OQ is a farther distance, but again, to measure it, you go point to point. And then we're going to go ahead and draw our, holding our point. We're going to draw a line through Q, then keeping our, I'm going to have to fix this, but keeping our point or distance, I'm going to draw another line. And obviously I'm going to have to extend my ray so that when it crosses, this becomes Q prime. All right. So now remember that we have this line between P and Q, but when we connect P prime and Q prime, we also get a line. So this line from here to here is going to be what? If we did this twice, then this line and this line is 2 times this line. So it basically maps a line to a line. This line can be moved up here because we can use translation. And remember that the line goes all the way through. But the distance is going to be twice the size of our PQ. So we can map a line to a line. So flipping back over, if you want to summarize this, I'm just going to flip through these. But here's a summary of the demonstration. But I'm going to go ahead and go through this. If you want to stop the video and take notes, you can. So basically, we have pulled this from proportion. Then we adjusted our compass. And remember that now we have 2 times the line length of OP. And now our line length is from O to P prime. And you can use your ruler to prove this. So if you wanted to measure it, if this was 1 inch, then now the line length should be about 2 inches. And the same on the other side. Then we repeated the process to locate Q prime. And we drew a line connecting the 2 points. All right, so return to your conjecture from before. Was it accurate? So the conjecture about a line. Can a line, when it goes through a dilation, does it become, or is it still a line? Well, you should have identified that the conjecture of a line mapping to a line under a dilation is correct. So we can map that line by just moving it, and it would map onto itself. So what do you think will happen if we select a different location for the center or for points P and Q? Go ahead and answer that question before you continue. Well, it doesn't matter where O, P, and Q are. Those we just kind of picked. That means it doesn't matter anywhere on the plane. The results are going to be the same. So a dilation would still produce a line, and that line would still be parallel to the original and can map onto itself. All right, so we're going to take a look at the drawing again and imagine using a transparency to translate the segment OP along vector OP to PP prime and translate the segment OQ along vector OQ to QQ prime. With that information, can you say anything more about lines L and L prime? Go ahead and write that down before you continue. All right, you should have written, since P and Q are arbitrary points, when we translate, or translations map lines to parallel lines, so that means L and L prime would have to be parallel. So that's another thing we can say about mapping a line to a line, is that they will be, or they will continue to be parallel. So So how do you think this is going to work if we change the scale factor to 3 instead of 2? Well, we would have to find P prime so that it is 3 times the length of OP instead of twice the length. And the same thing for point Q, or Q prime. So let's take a look at example 2. Do you think line L would still be a line under a dilation with a scale factor r equals 3? Would the dilated line L prime still be parallel to L? And the answer to that is yes. It's still going to be a line, and it's still going to be parallel, but that means it's just going to be, we're going to translate it twice, not just once. But the result is still going to be the same. So let's take a look at that. So basically what we're doing is, and we'll start with Q since that was our last one. If this is our distance from O to Q, and this is the same distance from from Q to Q prime, then if we do this again, and I'm going to go off the page, then my next line is actually going to be right here, or my next point. All right, and obviously I can't draw that. Let's go back to OP. So if I measure this, go back and measure the length of that, then again, when we multiply it by 2, now if I multiply it by 3, that means that when I put my point on P prime and draw a line, which is going to intersect, then my ray, if I extend my ray out, is going to intersect here. This would be the new P prime. And again, if you remember, it was kind of out here, but if I go ahead and draw that line, then over here it's going to connect, and you can see that L, if we call this L2, then it's also going to be parallel. And the distance between P prime and Q prime is going to be proportional to this size and this size, but they are all lines. If I take this line and map it up, it's still going to cover each other. All right. So the summary of this demonstration, this is what it would look like if you had a scale factor of 3. All right, so for example 3, what's going to happen if the center O is on line L? So what's going to happen if it's not off of it, but on it? Go ahead and write your prediction down. What do you think is going to happen? Well, if the center O, or 0 is on, it is O, we're on line L, we place points P and Q on L, then the dilations of points P and Q, which would be P prime and Q prime, would also be on L. That means that L and its dilated image, L prime, would coincide. So let's go ahead and take a look at that. So on your paper you already have this, but if I have a line, so here is L1, and I have the point of dilation O that is on line L, then we pick 2 more points. We'll call this one Q, and we'll pick another point over here and call this P. Well, again, using our compass, we can measure between O and P, which means if I take this and draw the cross and then do it again, then that means this point is going to be P prime. If I do the same thing, I better mark this before I forget. So this is now P prime. If I do the same thing to OQ, Okay. And then go ahead, use that same measurement. To cross again line L, then this becomes Q prime. Okay? So if we draw a line from P prime to Q prime, what do we notice? That L1 is the same as L2. Okay, the line is completely on itself. All right. So a summary of this demonstration is L prime is the same as L. I called it L1 and L2, but L prime is the same as L. And we like to say that dilations map lines to lines. All right, this last demonstration, we're going to take a look at what happens to rays. So if we do this, we're going to draw a point. This one you'll need to do in your math journal. This will not be in your classroom packet. So let's say we have a point. We're going to call this O. This is our dilation. And we're going to measure a distance of 5 away from this point. So this is where you're going to need to use your ruler for this. We'll call this P. And off in the other direction, we're going to measure this as 8. And we'll go ahead and call this Q. So if we draw a ray from P to Q, or P through Q, I should say, what's going to happen to this if we want to shrink it? Okay, so if we identify this, this is going to be the line length of P, O, and we just said it is 5 centimeters. And over here we have line segment of QO, or OQ, and this is equal to 8 centimeters. Well, if I take a dilation, let's say, of half of this, well, half of 5 would be what? It'd be 2.5. So I'm going to find where 2.5 is, and I'm going to mark that. So I've taken half of this distance, so now this becomes P prime. All right. I'm going to do the same thing between O and Q, which half of 8 is 4. And so this becomes Q prime. If we draw that ray through those 2 points, notice what happens. You still have a line that will map, but it has shrunk, and it would still map. If this is line L, then L prime is still a mapping. It's just shrinking instead of expanding. All right, so let's go ahead and summarize that. So our scale factor is 1/2 in this case. And they used A and B. I used P and Q. But you can just go through and take notes on this. OA was 5. OB was 8. Again, I used P and Q. But you can find half of those, which means you would take 1/2 of your line length. And finally, if you have, after our dilation, you have ray A prime, B prime, we would have had ray P prime, Q prime. We just used different letters. All right, what do you think would happen if we selected center O as a point on ray AB? Well, it would be the same if we dilated it. It would go the opposite direction. So even if we cut in half, the points would still be on the line, and it would just be half the distance, not the whole distance. All right, so now you're going to complete the exercises in the rest of the packet. You will verify experimentally that segments are mapped to segments. You will also verify that angles are going to be the same degree. And you want to revisit the conjectures you made at the beginning of the lesson and identify which are true. So here are the answers after you have gotten finished with the exercises. Check and see if your answers match and make any adjustments as necessary. So here is A and B. And here is C, D, and E. And to finish up or wrap up our discussion, these exercises demonstrated several properties. First of all, that dilations map lines to lines, rays to rays, and segments to segments. Dilations map angles to angles of the same degree. And you've also verified experimentally the theorem about dilations, which is, let a dilation with a center of O and a scale factor of R be given. For any 2 points, P and Q, in the play, we are going to say P prime is the dilation of P and Q prime is the dilation of Q. Then for any P and Q, the line segment P prime Q prime is equal to the scale factor times the line segment PQ. And for any P and Q, the segment joining P to Q is mapped to a segment joining P prime and Q prime. That was in exercise 1. The ray from P to Q is mapped to a ray of P prime Q prime. That was exercise 4, or example 4. And the lines joining P to Q is mapped joining lines P prime and Q prime, and that was throughout examples 1 through 3. And any angle is mapped to an angle of the same degree, which you did in exercise 1. So we have observed that the length of a dilated line segment is the length of the original segment multiplied by a scale factor. We have also observed that the measure of an angle remains unchanged after a dilation. So, in summary, we know how to use a compass to dilate when a scale factor is greater than 1. We know how to use a ruler to dilate when the scale factor is between 0 and 1. We know that dilations map lines to lines, rays to rays, and segments to segments. And last but not least, we know that dilations map angles to angles of the same degree. All right, that is it for this lesson.